Hello, Introduction to Java Programming. In this session, we discuss object-oriented programming concepts. We will understand what is object-oriented programming, what is object model, what is class, what is object, and what are the major object-oriented programming principles. Let's begin. Object-oriented programming is a paradigm. So what do you mean by a paradigm? A paradigm is a way or a style of programming to solve a problem. To solve a problem. So all the programs we write to solve problems only. So whether the problem is benign or very big, so you need to write a program by choosing one programming language. That programming language will have certain way, certain style actually. That is called a paradigm. Okay, for example, we are speaking of Java, right? So Java is an object-oriented programming language. C is a procedure-oriented programming language, right? So that means POP is a paradigm, OOP is a paradigm. We have something called functional programming. That's a paradigm. We have something called declarative. That's a paradigm. Okay, the way or the style of solving a problem, and if that style is incorporated into certain language, then we say this language belongs to this kind of paradigm. Okay, so Java is an object-oriented programming language. C is a procedure-oriented programming language. Python is a multi-paradigm actually. So Python is functional, Python is object-oriented. Okay, like that. Fine. Then let's define object-oriented programming. Okay, it's a paradigm, of course, we understood. So what does it do actually? So OOP organizes the problem, organizes the complex problem, or solves the complex problem. So it can be defined like this: solves or organizes the complex problem. So the complex word is important. The complex problem with the help of object-oriented principles. Okay, so how what is object-oriented programming means? Object-oriented programming is a way of programming. Okay, so we can also say here it's a way to solve or organize. It's a way to solve or organize the complex problem into the complex problem with the help of object-oriented principles. Okay, so in this approach, in object-oriented approach, what happens? A complex problem is taken. Complex problem is a big problem. Okay, object-oriented programming is for the complex problems. If it is a small one, you can actually do with C. That means procedure-oriented programming is fine. If it is bigger, then you need to go for object-oriented programming languages. Okay, and it uses actually object-oriented principles. What are the object-oriented principles? So there is an encapsulation, and there is an inheritance, and there is polymorphism, and there is abstraction. So these are the major object-oriented programming principles actually. So with the help of these principles, usually the problem is solved. The complex problem is solved. Okay, yeah, and the object-oriented programming follows object model. That means it's based on object model. OOP is based on object model. What is an object model? So that means in the definition itself, there is an object model. Okay, OOP is based on object model, and with the help of OOP principles, it actually solves the complex problems. Okay, so inherently, object OOP is based on the object model. So object model comprises of two things actually: what is called object and a class. Okay, so whatever the principle you speak of, encapsulation or inheritance or polymorphism or abstraction, so they will be on top of this object model only. Okay, and in OOP, we call this class is the basis. Class is the basis of Java. Otherwise, we can say object-oriented programming languages. Okay, so you may get doubt actually. So it's object-oriented programming, right? So and you are saying class is the basis. Is it not? Object is not the basis? Of course, yeah. It's an object-oriented program, so focus is on object only. Focus is on object only, and this object is specified actually. So how do you specify object? Object is a runtime entity. How do you specify an object? That means the object is actually created from the class. So the object, the major focus is on object, but how the object comes, from where the object comes from? Object actually comes from the class, right? So that's why we say class is the basis of object-oriented programming. Okay, so simply said, OOP is based on object model. That means OOP means it has object and a class as fundamental units, and with the help of this class and object, it organizes the complex problem with the help of object-oriented principles such as encapsulation, inheritance, polymorphism, and abstraction. Okay, yeah. So before we understand encapsulation, inheritance, polymorphism, abstraction, let's understand why actually one has to move to object-oriented programming. So before OOP, we have a POP. So because as I said, C program actually follows this particular POP, C, Pascal, etc. OOP, of course, almost all languages now which we are using are object-oriented. Java is object-oriented. The .NET, C# .NET or VB.NET are object-oriented. Even Python is object-oriented. Of course, Python can be many, but multi-paradigm. But majorly, it's also object-oriented. Even C++ can be object-oriented. Actually, C++ is a little different. C++ is C plus object-oriented. So you have two things actually in C++. So every C program is a C++, and you can write fully object-oriented programs using C++. Okay, so we can call it C object-oriented, and we can call it POP also. Okay, that means I can write a program completely like a POP one in C++. I can write a complete object-oriented programming program with C++, both. Okay, now the trend is object-oriented programming language only. When old languages, see, it has come in 1972. During that time, we have procedure-oriented programming languages. So why actually object-oriented programming is required? And yeah, so and what is this complex problem that is actually solved by OOP? So by using POP, you cannot actually solve the bigger problems. Okay, so POP is limited to only a smaller to a medium set of problems where the requirements are not changing frequently. So in order to understand that, let me actually take you to a slide actually here. Yeah, so this is actually the POP. In POP, you will have procedures or functions. Okay, and a program. So like C program, right? So what is a C program? If somebody asks me, I say a C program is a collection of functions, right? And there is one function called main function, and program execution starts from that. Okay, so in POP, the program is organized with the help of functions. Okay, and there are a good number of limitations. In POP, the focus is on procedure or a function, not on the data. If you observe here, so every function is having certain local data. That's not actual real data where your program are trying to solve. Okay, so the real data will be global data. So, but our focus is on actually writing on functions in POP, and little emphasis was given on data, but more emphasis was actually on procedures or functions. So that's the biggest drawback. Because of that, there is no security for the data. So that's why we'll say here, global variables have no access restriction. What happens actually with this means any function can actually change this data. See, there is one data, let's say X, and that is being used by some 10 functions. Now, if I change that global data in one function, what happens to the other functions? There is a problem actually. So there is no restriction, access restriction for the global data. That's one problem. And mostly POP follows the top-down approach. So in top-down approach, a top-down approach is a closed-ended approach actually. So you will see from the top view. So when you see from the top, you will actually draw a boundary. And so when the bound, you will actually write the code, and you will actually fill the boundary with functions, and it will be working for some time. Tomorrow, if new requirement comes, then you cannot fit that into that boundary. So new function, it is tough to fit actually. If you fit also, it's okay. One or two functions can be, um, we can actually incorporate. But nowadays, complex problems, they change requirements on regular basis, like a banking application. So every day you will have a new requirements, right? So you cannot keep on changing the POP kind of stuff actually. So that fails. So that actually happened in reality. So when 1972 C has come, and C was commercially available to everybody, and many people started writing bigger applications with C. But by the time of uh, late 70s, so that means at the late 70s, 78, 17, at that time, so many projects which were started using C has severe problems, and they actually collapsed. So many projects were stopped because C, you cannot actually write a bigger applications where requirements are changing. So C shoots actually for specific set of requirements. For example, there is a best language for embedded applications. Embedded applications requirements will never change. Only one fixed set of requirements will be there. You code it, you deploy it, and that's why most of our embedded systems like TVs, then ovens, fridges, ACs, all will run actually the C code. And most of other system software also you can write with the C, because the requirements will not change. Okay, so for the enterprise applications, the requirements will be changing on daily basis, right? So any ticketing application, any bank application, weather forecasting application, or any e-commerce application. So requirements will change very frequently. So that kind of problems are called complex problems, and POP failed to solve the complex problems. That's why object-oriented programming has come up actually. Okay, so these are some of the problems of POP. That's why we were actually into OOP. So in OOP, what happens? The focus is on data rather than functions or procedures. So as I told, actually, it's an object-oriented programming language. Orientation means focus. The focus is on object. What is object? Object is a real world thing. The real world thing contains what? Data, right? So other words, I can say it's a data oriented programming language. Okay, so that data you would identify an object, and similar. So in order to represent an object, you will actually make up a class actually. And that's how when you write a Java program, we say a Java program is a collection of classes. It's not collection of functions, it's a collection of classes actually. So you will start with a class. So OOP, the basis is class, but the focus is on object, identifying data. Focus is on data rather than procedures. And it of course follows bottom-up approach. So bottom-up approach is an open-ended approach. So there is no boundary. So sky is the limit for that. Okay, you can actually continuously grow your application. So today you have 10 requirements, you take them and you code it in methods of those classes which you identify, and you build it and you deploy it. And tomorrow, new requirement, just add that requirement uh, into a object, model it as a class, and just grow up actually. Okay, so this is always going to be um, open-ended actually. This is always going to be growing. So there is no boundary on object-oriented programming actually. So that's what actually the bottom-up approach. Okay, and as I said, the object-oriented programming is organized using the classes and objects. And of course, objects initially we identify. From that we create a class. Later, during the program execution, we create objects. So that is something interesting to understand actually in any of the object-oriented programming languages. Okay, some of the examples are Java, C++, C Sharp, Smalltalk, Simula, Python, etc. Okay, so this is basically about what is object-oriented programming and why it has actually come into picture. And the first commercial object-oriented programming language was C++, which has come in 1982. So Bijan Stostrup has actually um, has written the C++ language based on the OOP. And of course, Java has come after 12 years or 15 years later of C++. Java came officially into 1995. So it's actually some 13 years gap. Fine. So those details, of course, we are going to discuss. Let's understand only the object-oriented concepts now. So now what is an object? Simply said, okay, we will actually have next session completely discussing about object and class in detail. And we are going to write a class and we are going to create an object from it. And before that, let's understand now kind of definition kind of things, or let's have an understanding of what is object and a class. So as I told, object has to be identified and it is a real world entity. And object oriented programming models the real world. So objects you will identify from a real world only. For example, if I speak of a student, a particular student is an object and the student has data. A particular employee is an object. That employee has a data, right? So whatever you see in the real world. So for example, the laptop I am using, the mobile I am using, okay, the pen you are using, the book you are reading, right? These are all objects. They all have certain data. Okay, so properly, if at all we want to define, so we'll say an object is a real world entity which has state, behavior, and identity. Okay, let me write actually here. So how to define an object? Object is a real world entity. Okay, simply said, we'll say it's a real world entity. Real world entity which has three properties. What are those three properties? It has a state. State means the data. That means the values. For example, I speak of particular student. So the particular student rule number is 101. Particular student name is, let's say, some ABC. The particular student identity actually. So the particular student is identified with identified actually. That means the particular student is uniquely identifiable from other person actually. Okay, so this is one object. So 101 ABC. Let me maybe this is it, right? So 101 ABC and maybe having certain GPA 8.9 and maybe belong to certain city, some city equal to Hyderabad or Pune, whatever it is. This is the state actually. Now there is a behavior. There is a behavior. We speak of behavior. A real world entity which has state, behavior, and identity. Identity. Okay, the state is data. Data possessed by that particular object. State means data possessed by that particular object. Behavior is actually methods. Behavior is actually methods. So I would like to get the GPA. Okay, I should have a method to get it. I should get all student data. I should have a method. I want to update the GPA. I should have a method. So in order to work on this data, we will have behaviors, and those are nothing but methods. And identity is actually how this object is uniquely identifiable from other objects. Okay, each object is actually unique. Okay, objects should be uniquely identifiable from other objects. So that's a feature of identity. So each object, so this is a student object, and like that I will have a number of student objects. So this student, that student, some other student, I could able to identify a particular student. That's actually the identity. Okay, so now S1 is this student, S2 is some other student, S3 is some other student. Like that I can actually differentiate one student from the other student. So that's what is actually an object. And what is a class? So class is actually kind of a category. Class is actually a category for all students, right? S1, S2, S3 belong to a student category. All employees, employee 1, employee 2, employee 3, employee 4 belong to employee category, right? So student, employee, then book. Okay, then whatever you actually see like a class, a group, a category, or classes actually. Okay, so how do we define actually that one? So we define like this: a class can be defined like a blueprint. So that's not a real world entity, that's a logical actually. Class is, let me tell you, this is a logical one. So that's not a physical one. Okay, so a student, a book, car, dog, animal, man, human. So these are all categories. They are not actually physical. Okay, my book, my car, my student, these are all objects. Okay, class is logical and it kind of a blueprint or a template. It's a blueprint or template, which is actually to create objects. A blueprint or a template which is used to create objects. That's what actually a class. Okay, you need to understand the definition actually. Uh, Otherwise, you need to able to clearly identify what is an object and what is a class. A class is a blueprint or a template, just like a student, an employee, book, car, etc. And an object is a real world entity. My car, your car, okay, this book, that employee, this pen, this laptop, are objects. Okay, they are physical and classes are logical actually. So let me show you some example in my slides actually here. For example, if you see, I'm saying it's a Daniel's car, right? It's not car. Car is a class, but Daniel's car. So Daniel's car color is ash color. It's a BMW, and it has some speed, 50 kilometers. So this is the data. Okay, an object will have data associated, state associated. A class is a category. Data will not be there for a class. Just properties will be there. So that difference you need to understand. So that I'm going to actually show you over here. So class is a blueprint that defines objects of certain kind, and a class is used to manufacture or create objects. A class is a template which is used to create objects, and every class is an entity. As an example, if you see a class which is a logical one actually, okay, but this is my car, this is your car, this is somebody car. So these are objects and this is actually a class, and class has certain properties: color, make, model, mileage, speed, and there are methods actually. So when you give color, make, model, mileage, speed as values and give some identity, then it becomes an object. Car 1, car 2, car 3. So those are the objects actually. So let me show you other objects. So this is my car class and these are all objects which has certain data. This is my dog class. Dog doesn't exist in reality, but this is my dog, this is your dog, this is somebody's dog. This actually exists, right? So this difference you need to understand actually. So class and object. Okay, so in the same fashion we actually have uh, object oriented principles. So let me actually tell you in a simple fashion. Encapsulation is actually a wrapping up of data and methods into a single unit. Okay, inheritance is actually exists among class and interfaces in Java. So what happens in inheritance is also a real world thing. So children can acquire properties from their parent. In object oriented programming language also, a class can acquire properties from other class. And then coming to the polymorphism, the polymorphism is the ability to change, or the ability to take many forms is the polymorphism. Abstraction is actually a design principle for solving the complexity. Abstraction says exhibit the essential features and hide the irrelevant details. So each and everything is a big concept that we need to understand. So let me actually go and quickly tell you about these things here. Yeah. So coming to abstraction, so just I'm telling of abstraction. Here, if you see a car, you will see the car like this. See, this is Daniel's view of car object. When we see a car, we'll see what is the color, what is the how many seater, okay, and what's the fuel type. Okay, so all these things we will see. But the background details, so background details, how engine and all other things actually, right? So that we will not bother, right? So these are the essential features, whatever we see, and the background details also will be there, but we will not actually worry about that. So that's actually is ensured by abstraction. So there is something called specification, there is something called implementation actually. Okay, so Abstraction is the process of hiding the irrelevant details and exposing only the essential features of particular object. Okay, so in Java, this abstraction is achieved with the help of interfaces and abstract classes. Okay, those are the units that we create and we will actually work with. Okay, so another example I will give you for abstraction. If you see at ATM, so we will actually see the ATM as something where we will actually insert card and we will actually deposit or transfer money. But what is actually happening underlyingly, right? So that we don't bother actually, right? So what we see is actually the specification, and what is background is there, that is actually the implementation. So we have to separate specification and implementation. So, and these specifications are mentioned in abstract class or interfaces, and implementations will be written in classes actually. So that's about the abstraction. We will understand this in detail when we actually go to interface and abstraction part, abstract class part. So encapsulation is actually wrapping up of data and methods into a single unit. So in a class, what we do actually, a class is actually having two compartments. One is data and another is methods. So that data is tied with methods very strictly. So in a class, so that data cannot be accessed by anybody else. Only it can be accessed through methods. So if you observe in C language or in POP, your data has no restriction. Any function can access global data, right? So there is a problem for that. But here in class, you will have data mentioned, and this data is accessed only with the methods defined in that particular class. This is called encapsulation. So by this, you can secure the data, you can restrict the access to the data. And coming to inheritance, inheritance is a real world problem. It's one of the major object-oriented principles. So here, a class acquires properties from other class. Okay, so we'll have superclass, subclass. So from superclass, a subclass acquires the properties. We can also call as base class and derived class. Derived class acquires properties from the base class, and we can also call as parent and child. Child acquires properties from the parent. Okay, so this is simply what is inheritance, and through inheritance, what happens is code reusability will happen. Okay, already code is available in a class, and I can inherit it, and I need not to write actually from the scratch. Okay, I will get all of them and just I can use it. Okay, of course, there are three major things that are going to happen with inheritance. Okay, and there are different types of inheritance. This, of course, we are going to discuss once we start with inheritance again. So just I'm going to give what is object-oriented programming and the concepts. Yeah, so there are different types of inheritances which we will understand. So then coming to the last object-oriented principle, that is polymorphism. Polymorphism is the ability to take many forms. For example, if you see here, this is a good example for polymorphism. So whenever I say speak, so cat speaks different way, dog speaks different way, and duck speaks different way. The method is same. The speak is the method, and the objects are responding differently. So the ability to take more than one form. Speak is actually taking different forms actually here, right? That's what the polymorphism. Yeah, so the ability to take more than one form is called polymorphism. So to see another example, I have a draw method. When I say draw, a triangle is drawn here. When I say draw, circle is drawn here. When I say draw, square is drawn here. So the draw method is called with different objects and behaving differently. That's called polymorphism. And in Java, methods will exhibit polymorphism. So let me go back to my slide here. So encapsulation, the class actually has the encapsulation, and inheritance is possible among classes and then interfaces and also abstract classes in Java. Okay, and from coming to polymorphism, methods will exhibit polymorphism, and abstraction is actually achieved with the help of abstract class and interface. Okay, so these are the implementation units in Java. So this is briefly about what is object-oriented programming. So finally, The OOP is a way to solve or organize the complex problems with the help of object-oriented principles. So OOP is based on object model. So you need to understand what is object and what is class. And it actually solves the complex problems with the help of object-oriented principles. So just to have an idea, I gave what is an actually encapsulation, inheritance, polymorph, and abstraction. Okay, so we'll actually discuss all of these things in very detailed way by taking one property or one principle at a time. Okay, so that's all for this session. Hope you understand. See you in the next session where we discuss thoroughly about class and object. Thank you.